everyone, welcome to today's video. In today's video, we are going to talk about exponent laws. And the topics we are going to cover in today's video will be exponent definition review, 100% tested identities, and practice examples. So first, let's take a look at the concept of an exponent. So, if we have something like this, a to the power of b, this is a typical exponent, and we call this a the base, and this b the exponent. And a to the power of b just simply means that there are ba's multiplied together. Example would be 5 to the power of 3, or we can call it 5 cubed. It would be 3 5s multiplied together. So it would be 5 times 5 times 5 equal to 125. Next, let's take a look at some very commonly tested identities. So, do you guys remember what this symbol means? This means for any a or b that is not 0, and a and b are real numbers, and for any m and n that are integers, we have the following identities. So the first one we have a to the power of m times a to the power of n equal to a to the power of m plus n. Why is that? Remember, if we have a to the power of m, it means we have m a's multiplied together. And we multiply by a to the power of n, which means there are n a's. So if we take them together, how many a's are there in total? There will be m plus n, this many of a's multiplied together. That's how we get this identity. Next one, a to the power of m over a to the power of n equal to a to the power of m minus n. Similar approach, we can understand this identity. So for numerator, we have m a's up here. So m a's. On the denominator, we have n a's. So some of them would cancel out. So some of them a would cancel out. And what do we get from this, like the simplified version? We will have a m minus n, this many a's left after the simplification, after the cancellation. And m minus n could be positive, could be negative, depends on the value. Next one, ab bracket to the power of m. So we can distribute this m to both variables, so which gives us a to the power of m times b to the power of m. Next, a to the power of m bracket to the power of n, which gives us a to the power of m times n. We need to really be careful about distinguish this identity from a to the power of m times a to the power of n equal to a to the power of m plus n. We need to distinguish these two. Next, a to the power of 0 equal to 1. So any real number to the power of 0 gives us 1. How can we prove this? So we can prove as follows. So let's take a look at the following patterns. What do we get from 3 to the power of 5? 3 to the power of 5 should give us 243. What about 3 to the power of 4? 81. 3 to the power of 3, 27. 3 squared, 9. 3 to the power of 1, it gives us 3. So we subtract 1 from the exponent every time, and the result will be divided by 3 each time. What about next pattern? If we minus 1 again, we get 3 to the power of 0. So according to the pattern, we will divide 3 to this number again, which gives us 1. That's how we know that any real number to the power of 0 gives us 1. Next, identity. A to the power of negative m equal to 1 over a to the power of m. So whenever we have a negative sign in our exponent, we just move it to the denominator, and we have 1 on top of it. Next identity. A over b bracket to the power of m. We can still, similar to ab to the power of m, we can distribute this m to both variables. We can distribute this m to the numerator and the denominator respectively, which gives us a to the power of m over b to the power of m. Next is a fairly important one, a to the power of m over n, which will give us a to the power of m with a nth root. So the numerator of this fractional exponent will become the exponent inside the radical, and the denominator of this fractional exponent will become the index of the radical. So it's the nth root. Next, what about a to the power of negative m over n? Since we have this identity right over here, so we can say that a to the power of m over n is a to the power of m with the nth root, and then we have a negative 1 outside of this bracket. And as we see right here, whenever we have a negative sign in the exponent, we just move it to the denominator with a numerator of 1. So we can put this thing inside the bracket down to the denominator with a numerator of 1. So these are some of the commonly tested identities of exponent laws. So now we can do some practices to affirm our knowledge. First one, 6a squared over 2a to the power of negative 8. So whenever we see a fraction, we always need to simplify it. So let's do this question first by isolating the constant from both the denominator and numerator to make it clearer. So it's 6 over 2 times a squared over a to the power of negative 8. So what is 6 over 2, which is simply 6 divided by 2, we get 3, and a to the power of 2 over a to the power of negative 8. As we learn from the identity, whenever we have something like a to the power of m over a to the power of n, which gives us a to the power of m minus n. So similar approach here, this would be a to the power of 2 minus negative 8, which will give us 3 times a to the power of 2 minus negative 8 gives us 2 plus 8, which is 10. So the answer to this question would be 3 times a to the power of 10. Next, 16 x to the power of negative 1 over 3 times y. So we cannot do any further simplification for 16, nor y. So we only need to deal with this x. So let me rearrange this, times x to the power of negative 1 over 3. So we leave this 16y outside here. And what would be x to the power of negative 1 over 3 mean? So as we know that whenever we have a fractional exponent, it means that the numerator will become the exponent inside the radical, the exponent for the radicand, and the denominator will be the index of the root. So x to the power of 1 over 3 will become x root, cubic root of x. However, we have a negative 1 outside of here, so we still need to consider that. And as we know, whenever we have a negative sign or negative 1 in the as an exponent, we just move the whole thing down to the denominator. Down to the denominator with a numerator of 1. So will be something like this. And then we want to perform our final step by multiplying 16y to this fraction, which is simply putting 16y up to the numerator. So this will be the full step for this question. So 16 times x to the power of negative 1 over 3 times y equal to 16y over cubic root of x. Next question. 4x cubed bracket to the power of negative 1 over 2. So the first step we would like to do, based on the identity ab to the power of m equal to am times bm, we can distribute this negative 1 over 2 to both term or multiplier. So 4 to the power of negative 1 over 2 times x to the cubed to the power of negative 2. Next, we can simply evaluate this 4 to the power of negative 1 over 2. So similarly, this numerator will become the exponent of the radicand, and the denominator will become the index of the root. And we have a negative sign of it, so we move the whole thing down to the denominator. Then we times x cubed to the power of negative 1 over 2. So as we learn from this identity, when we have a to the power of n to the power of n, it gives us a to the power of m times n. So similarly right here, x cubed to the power of negative 1 over 2 gives us x to the power of 3 times negative 1 over 2. So now we can simply evaluate and simplify the rest of these things here. So 1 over 4 square root. So the square root of 4 will be 2. So 1 over that would be 1 over 2. Times x to the power of 3 times negative 1 over 2 will give us x to the power of negative 3 over 2. So we can perform the fractional exponent law again. We can leave 1 over 2 right here, and this 3 on the numerator will become the exponent of the radicand, and the denominator 2 will become the index of the root. And we have a negative sign, so we put everything down to the denominator. And then we can simply multiply these two together by multiply the numerator together, 1 times 1, and the denominator together. So 1 times 1 is 1, and the fractional line, and 2 times the whole thing, which is basically 2 times the whole thing. So 1 over 2, the square root of x cubed, would be the simplified answer for this 4x cubed bracket to the power of negative 1 over 2. Next question is a bit more complicated. So the question says x to the power of 2y plus 7 times x to the power of 3y plus 2 over x to the power of y plus 8. So how can we do this? So first of all, let's deal with the numerator first. So as we learn from the identity, whenever we have a to the power of m times a to the power of n, so same base, which is x in this case, so same base, different exponent, and the operation we are performing right here is multiplication. We can just simply add those two different exponents together. So in this case, same base, x, different exponent, and the operation we are performing is multiplication. So we can simply add the two different exponents up. So 2x to the power of 2y plus 7 plus 3y plus 2. And the denominator, we cannot do much things about it right now, so we can just leave it here. And next, we want to just simplify the numerator, the exponent of the numerator, by combining like terms. So we can see that we have a 2y here and a 3y here and two constant here. So 2y plus 3y will become 5y, and 7 plus 2 will become 9. So this thing will become x to the power of 5y plus 9. And still, we leave our denominator as it was. Now, we can perform another identity right here. So if we have two same base, but with different exponents as denominator and numerator, we can simply, and the operation right here is fraction, which is division, we can simply subtract the exponent of denominator from the exponent of the numerator. So in this case, it will become x to the power of m minus n. So the exponent of the numerator, in this case, which is 5y plus 9, and we better give a bracket here, minus the exponent of the numerator, which is y plus 8. So then we want to just minus those two. So 5y plus 9 minus y minus 8, we extract the bracket, and since it's a minus sign in front of it, we want to change this plus sign to minus. And then we want to combine like terms again. We have 5y here, we have minus y here, and we have two constants here. So it will become x to the power of 5y minus y, 4y, and 9 minus 8 plus 1. So this giant beast here will be simplified using all these identities and combining like terms, extracting brackets, 2x to the power of 4y plus 1. And next will be our last question of today, which is a question that's fairly challenging and using a fair amount of the identities we have talked about earlier in this video. So the question says, 49 times bracket 7w to the cubed x to the power of negative 5 z to the power of 4 over w to the power of negative 3 times z bracket to the power of negative 2 times 14 bracket x to the power of 4 za to the power of 8 bracket to the power of 0 over x to the power of negative 8 times z to the power of 8. So how can we solve this thing right here? So now we really want to incorporate the order of operation, bad math, into the evaluation of this question. So B is bracket, just a little recap here. E is exponent. D and M, they have the same priority, which is division slash multiplication. And last but not least, A and S, they also have the same priority, addition or slash subtraction. Okay, so now based on this order operation, we can start working on this question. So first we want to evaluate these brackets. So we have one bracket here and another bracket right here. So you want to evaluate those two first and leave everything else as it was. So 49, we just leave it there. And how can we do this? So basically, we can see that the bracket has an exponent of -2. But the evaluation of this bracket is to simplify the things that is inside the bracket. So we want to simplify this giant beast right here inside the bracket. So how can we do that? So still, we can isolate, I'll call them same base with probably different exponent, isolate them. So we can do this, 7/1 times w to the power of 3 over w to the power of -3 times x to the power of 5, and there is no x to the power of something in the denominator, so we can say 1 times z to the power of 4 over z to the power of -2. And this clearly is not simplified, but we can do that in the next step. And for this bracket is fairly simple. So using the identity, any real number to the power of 0 equal to 1, we can say that this thing is just 1. So, wrong color. So we can say that it is basically 14 times 1 over x to the power of -8 and z to the power of 8. Not -8. 8, we just leave it there. And next step, we can do further simplification for the mass inside this bracket, inside the first bracket. So 49, we leave it there. And we can see that 7/1 is 7. And all these fractions, we can use the same identity, a to the power of m over a to the power of n equal to a to the power of m minus n. So w to the power of 3 over w to the power of -3, which it will just become 3 minus -3 as the exponent of the same base w. X to the power of 5 over 1 will just become x to the power of 5. And last but not least, z to the power of 4 over z would become z to the power of 4 over 1, minus 1, because here's a 1 hiding here. And the whole thing is to the power of -2. And this thing, we still leave it here because we still haven't fully simplified the things inside the bracket. So now, let's see if we can simplify everything. So 7 is 7. W to the power of 3 minus -3 is 3 plus 3, which gives us 6, times x to the power of 5, and z to the power of 4 minus 1, which is 3, and -2. And the final part is the same thing. We can put it here. And also 14 times 1 is just 14, so I'll just write 14 here. So up until this step, we have fully simplified the thing inside this bracket. So based on bad math, next we are going to work on exponent. So bracket down. Next, exponent. So what exponents are there that can be further simplified? It will be this -2 here. So based on the identity, AB bracket to the power of m equal to a to the power of m times b to the power of m, as we can distribute this m to both multipliers. We can distribute this -2 to 7, to w to the power of 6, to x to the power of 5, and z to the power of 3. So we can do that respectively. So it would become 49 times 7 to the power of negative 2 times w to the power of 6 to the power of negative 2 times x to the power of 5 to the power of negative 2 times z to the power of 3 to the power of negative 2, and times the same thing over here. And now let's see if we can simplify the distributed bracket. So 7 to the power of negative 2, it is simply 1 over 7 to the power of 2. Why is that? Because we can use the identity a to the power of negative m equal to 1 over a to the power of m times w to the power 6 times to the power of negative 2. We can use the identity a to the power of m to the power of n, gives us a to the power of m times n, which is w to the power of 6 times negative 2 gives us negative 12, and x to the power of 5 to the power of negative 2 gives us x to the power of 5 times negative 2, which is negative 10, and z to the power of 3 to the power of negative 2, which gives us z to the power of 3 times negative 2, which is negative 6, and times the same thing. So this thing, we can just leave it there first. And now let's see if we can do the final simplification inside this distributed bracket. So 1 over 7 squared is 1 over 49 times w to the power of negative 12. We can use the same identity right here. So a to the power of negative m equal to 1 over a to the power of m. So this would be equal to 1 over w to the power of 12 times 1 over x to the power of 10 times 1 over z to the power of 6 times, let me just copy this down, which is 14 x to the power of negative 8 and z to the power of 8, which is the same thing right here. Okay, so now we can put all these things into a single fraction again. So numerator multiply together, which is just 1, because 1 times 1 times 1 times 1 is 1, and 49 w to the power of 12 times x to the power of 10 and z to the power of 6, and times the thing right here. And now we can multiply, since all these three, this 49 is basically 49 over 1, all these three are fraction, so we can just multiply them together by multiplying numerator together and multiply denominators together. So the numerator would become 49 times 1 times 14, and the denominator would become 1 times 49w to the power of 12 times x to the power of 10 times z to the power of 6 times x to the power of negative 8, z to the power of 8. So we can see that we have a 49 on top of in the numerator and a 49 in the denominator, so we can cancel them out. And these two ones, we can just omit them. So we have these things left. And interestingly enough, we have a x to the power of 10 here and a x to the power of negative 8 here. They have the same base and they are multiplied together. So we can perform the identity a to the power of m times a to the power of n. Same base, different exponent, operations multiplication. We add those two exponents up. And the same thing happens to these two z here. So we can say that it will become, on the numerator we only have 14 left. On the denominator we have this w to the power of 12, which we cannot simplify. And this x to the power of 10 times x to the power of negative 8 just becomes x to the power of 10 plus negative 8, which is 10 minus 8, which is 10 to the power of 2. And z to the power of 6 times z to the power of 8 is z to the power of 6 plus 8, which is z to the power of 14. Thank you very much. I think that's all for today's video. Thank you for watching.